Okay, so the other day I was asked by a student whether it mattered when we had an expression n to the power of n to the power of n, whether it mattered the order that we did it, whether we did n to the power of n and then raised that answer to the power of n, or whether we did n to the power of n here and then raised this n to that answer. And it certainly does matter, as we will see when we answer this question here, which is for which n is n to the power of n to the power of n plus all the atoms in the universe less than n to the power bracket n to the power of n. I'm reliably informed by Google that the number of atoms in the universe, I haven't counted, so I have to take their word for it, is number of atoms in the universe is 1 times 10 to the 80, which is the number 1 with 80 zeros after it, which is quite a lot. So let's have a look. So n to the power of n. So first of all, n to the power of n to the power of n. Let's have a look at that. That basically is n to the power of n times n to the power of n times n to the power of n times n to the power of n times. So there are n of these, and by the basic law of indices, that equals n to the power of n squared. So n to the power of n to the power of n is the same thing as n to the power of n squared, which is clearly less than or equal to n to the power of n to the power of n, depending on the values of n. So let's just have a quick look at n equals 1. Let's just take n equals 1. n equals 1. So n to the power of n to the power of n, which is n to the power of n squared, is equal to 1. And n to the power of n to the power of n is 1 to the power of 1, which equals 1. So it's the same. What about for n equals 2? Well, n to the power of n to the power of n equals n to the power of n squared, which equals 2 to the power of 4, which equals 16. And, sorry, n to the power of n to the power of n equals 2 to the power of 4, which equals 16. So for n equals 2, again, n to the power, depending on, it doesn't make any difference which way you do the brackets. Let's have a look at n equals 3. So now for n equals 3, n to the power of n, brackets to the power of n, which again is n to the power of n squared, is equal to 3 to the power of 9, which is, off the top of my head, 19,683. Whereas n to the power of n to the power of n is equal to 3 to the power of 3 to the power of 3, which is 3 to the power of 27, which is, again, off the top of my head, 7,625,597,484,987, I think, which is approximately 7 times 10 to the 12. So it is clear that even for n equals 3, n to the power of n to the power of n is vastly bigger than n to the power of n to the power of n. But it is not bigger by the number of atoms in the universe. So let's have a look at n equals 4. For n equals 4, n to the power of n to the power of n, which again is n to the power of n squared, is 4 to the power of 16, which is, I'm reliably informed, 4 times 10 to the power of 9. Whereas if we take n equals 4 for n to the power of n to the power of n, which is 4 to the power of 4 to the power of 4, which is 4 to the power of 256. I haven't worked out this in my head, I had to use Google again. 1.34 times 10 to the power of 154, which is 1 with 154 zeros after it. So for n equals 4 or greater, n to the power of n to the power of n is greater than n to the power of n to the power of n, not only plus all the atoms in the universe, but all of the atoms in the universe if each atom itself contained an entire universe of atoms. So there we go, it doesn't matter which way the brackets are.